target, we're going to take two mixed numbers and we're going to multiply them. And Zainab said when we were going over this target that we could use what, Zainab? Zainab? Okay. Or we can use a what?
Mathematical representation.
Okay, good. And by doing two of these, what is it going to help us do with our problem? Talk about it, guys. And what does that mean? Okay. Show me 5, 4, 3, 2, 1. That was almost perfect. We almost had it, everybody, following our norms. Thank you, Cheyenne. So, Cheyenne, when we say justify, what do we mean by that?
What we mean by justify is, I don't know, yeah, I think it means,
Go ahead, help her out.
So justify, I told her that you take your equation and you basically just plan it out on a representation.
Uh-huh. And what does that do by doing it two different ways? What are you trying to help do? What's that, Zena? And Dara, add to our conversation.
What it means by justify your answer is to prove your answer to your equation.
So what did she say, Cheyenne? Whoa, let's start again. Go ahead. Go ahead, Dara. She's doing it now.
So what it means by justify your answer is that it's to prove your answer to your equation.
Prove your answer to your equation. And what does that mean to you, Matthew? What's that? To show your work. And why would you need to show your work, Regan?
Because it helps you to justify what you didn't justify.
Justify your what?
Your work.
Your work. And finally, it helps you to justify your what, Josh? Your final what? Your final answer. Okay. Let's come up to the board, okay? Move yourself into a learning position. So, we have a story problem here today, okay? And this one is a problem that you're going to have to use the algorithm and also a mathematical what? Representation. You're going to have to use an algorithm and a what? A mathematical representation. Come with me, Alexis. You've got to be part of the conversation now. Okay? So, I have set up the algorithm up here based on this problem. So let's take a look at the problem here, and I'll read it just in case it gets a little bright in here. So, eyes on the board. Marnie was making her delicious chocolate brownies, and Ethan decided that he wanted to help. What does the next line say? Okay. She had measured out 3 1/4 sticks of butter, but then wanted to make the recipe 2.5 times bigger just in case Ethan messed up part of it. Raise your hand if you think that's a possibility. Absolutely. Okay, so real life problem here. How many sticks of butter would she need? Okay, how many sticks of butter would she need? Now, yesterday we talked about the algorithm of this, and we did certain steps for the algorithm, and that's just the math type problem. Somebody used another word, it began with E, and it's on the target board. So we wrote a what?
Equation.
What do we write, class?
equation.
We wrote an equation. So I wrote an equation here without the answer, and I'm going to try to use the algorithm. But let's see if you can remember the steps. So talk about the steps. Go and help me through it. What's the first thing you do? What's the next thing you do? So go ahead and start talking here, guys. I want to listen in. 4, 3, 2, 1. Anybody want to take a risk and come to the algorithm? Come to the algorithm. Alexis, thank you for coming back into the fold. Go ahead, Alexis. Go on up and take us through the steps, okay? And while you take us through the steps here, I'll write them. And if you need any help, just ask for out there, okay? And Jordan, looking at our time, can you give me 5 minutes to do this algorithm, okay? And then we'll move into our groups. Here you go. All the markers in the world PDF. Glorious colors. Go ahead, choose. Choose. You do the algorithm. Do you want to do it here or do you want to do it here? Where are you more comfortable? Over here? Okay, you do the smart board. I'll do it on the whiteboard. And I'll kind of do what you do. See if it works for you. It's okay. Okay, stop. Where did you get those numbers from? I don't see those numbers at all. Can you circle those numbers for me? Kylie, can you tell me how they wrote those numbers? Why? How did they write them in the problem? She said they wrote them with words. Raise your hand if you've seen story problems or word problems where they write them with words. Yeah. Okay. So now, Alexis, what are you going to do? What did she say she's going to do? Did you hear her, Antonio? A little louder so Antonio can come into the conversation.
The first step is to change them into a fraction.
What did she say, Antonio? She's going to turn them into what kind of fractions? Improper fractions, yeah. Okay. How do you do that, Alexis? Nice job, Josh. Okay, so what did you get for it? That's okay, take your time. What did she do there? What did she do to get 13/4 and it looks like 5/4? What did she do there? Talk. How did she get those? So, rolling it out. What'd she do there?
She did the 1/2
Show me 5, 4, 3, 2, 1. Okay, what did she do there? What did she do to get those improper fractions? I like a new voice. Reading, go ahead.
She turned the 1/2 into 2/4.
Show me what you mean. What do you mean?
1/2, the 1/2, and there's a 1/4, so she turned the 1/2 into 2/4.
Where's the 2/4 up here? I don't see 2/4.
So she changed the 1/2.
She changed the 1/2 into how many fourths?
2/4. So 1/2.
Are you talking about this one?
Yeah.
5/4. How'd she get 5/4? Read it.
Because she did 2 times 2 plus 2 equals 4, and then 4 plus 1 equals 5.
And got 5/4. So what he was saying is the 2 times 2 is 4, plus the 1 is 5, and you keep it in. Give Reagan and you and I if you agree with him. Okay, and then she did that with the other side. So Alexis, what would you do next? Okay, go ahead. So she did the 4 times 4 and she got 16. Give her a U and I if you agree with that for the denominator. Okay? And now what are you figuring out? I want you to watch what she's doing to deal with that 5 times 13. If you can do 5 times 13 in your head, get a number and be ready to check her work. If you want to scratch it in your notebook, you can do that too. What'd you get? That's correct. That's correct. 75, yeah, Dara?
I got a question.
Yes.
For where she got 5 4s, she doesn't need to change the denominator. She could leave it as a half. Because we're multiplying it, not adding or subtracting.
So, thank you, Jordan. So she did 4 times 4 is what?
16.
Right? So you wouldn't have changed this?
You could.
You wouldn't have to because you had to multiply those.
Yeah, but you leave the. Did you put 12 for the denominator on 3 and 1/4?
What's 3 times 4?
Yeah, no, she tried to.
3 times 4 is 12.
Plus one.
Plus one.
Yeah, but that one's right. But
That one's right? What do you think about this one?
Because she could have just left the 2 as the denominator.
She could have, well, how?
Because
What is the process? Tell me what the process is for making an improper fraction.
like it could be 5 halves. And then because you told us when we multiply, we don't have to do the LCM for it.
Right? You don't?
So why is it 13 fourths and 5?
What's 2 times 2?
It's 4.
Plus 1.
5.
5 4s.
Or is it 5 halves?
It's 5 halves.
No, it's 1 here to multiply.
What do you think, Alexis? Denominator should be 2? Talk, should it be 4 or 2? Go.
4. 4. 5. That now it's a half. It can be any number.
Okay. Show me 5, 4, 3, 2, 1. Let's do this one. Let's change this to an improper. Ready? Hey, Hunter, need you. Need your eyes. Need your brain. Change this to improper. Ready? 4 times 2. That's not our class. That's part of our class. Everybody now. 4 times 2.
8.
Plus 1.
9.
Equals 9 eighths or 9 halves.
9.
8.
9 halves.
Where's your thing?
9 half.
Remember, the denominator does not what?
Change.
Change. Okay? So let's do this again. Now what do you get? Just get a different is that going to make a difference, guys? Absolutely. Absolutely. Okay? So let's count by eights. Ready? 8, 16, 24, 32, 40, 48, 56, 63, 72. So that gives us how many? 9 holes. And how many left over? 3. So this should equal 9 and 3. Okay, hey guys, now let's come up. Thank you so much, kiddo. You were terrific. Hey, show me 5. Because I have kids scribbling in their notebooks and I love that. Writing all sorts of cool things down. Hey, now we've got the algorithm. If this is correct, then we need to what? Justify our answer. And we're going to do that with a what? Okay, we're going to do that at the kiddie table. Okay, so groups, a little bit different. Ouch, Zern, that's no different. Yesterday's news, over the shelf table. Choose 2 problems. Multiplying fractions by mixed numbers would be at the kiddie table. Here's the difference. Regan. No, didn't ask you to move yet. Classroom pass. Using an algorithm. You know what that means again. Solve large number multiplication problems. I took your decimals away from yesterday. The examples are pinned to the math board in the back, and there are examples on your papers. There's 3 levels. You choose the level you're most comfortable with, standing like this. And we are ready to move in 5, 4, 3, 2,